Okay, whenever we're dealing with radical equations, it's very important that we check our solutions. And the reason why it's important that we check those solutions is because some of those solutions may be extraneous. So an extraneous solution is a simplified version of an equation that does not satisfy the original. Okay, and we're going to see more closely what that means in a little bit. And the way that we figured that out is you just plug your answers back into the original. And if you get a false statement, so if you get like 5 equals -5, that's not true, then whatever solution you use to get that false statement is extraneous. Alright, so let's actually look at what that looks like. Here we have the square root of 2x minus 1 plus 5 equals 2. So to solve this equation, the first thing I need to do is isolate this root. Right now there's a 5 being added to it. So to both sides of the equation I need to subtract 5. Okay, now I've got that the square root of 2x minus 1 is equal to -3. Now, since the root is isolated, I can get rid of that root by squaring both sides. So, squaring the square root of 2x minus 1, I have 2x minus 1 is equal to -3 squared is 9. Now it's just a linear, so solve for x, I add 1 to both sides. 2x equals 10. Divide by 2. And x equals 5. So now we've followed all the rules, right? And we got x equals 5, but we need to check and see, does this solution actually work? Okay, does it satisfy the original? So I'm going to go back and I'm going to check this 5 by replacing the x's with the 5. So I've got the square root of 2 times 5 minus 1 plus 5 equals 2. Well, this is the square root of 2 times 5 is 10 minus 1 is 9 plus 5 equals 2. Well, the square root of 9 is 3, so this is 8 equals 2. That's not true. So I got a false statement. That means that this 5 is extraneous. So this problem has no solution. Now here's the thing. I knew that I was going to get an extraneous solution a long time ago because right here I saw that the square root of 2x minus 1 equals -3. Will a square root ever equal a negative?
Nope.
No. So I knew that there was going to be a problem. Okay? But here, yeah, we followed the rules, but this just has no solution. Alright, in this example we have x plus 1 equals the square root of 7x plus 15. It's like the last problem in the sense that it has a square root, but it's unlike the last problem in that it has an x on both sides of the equation. Okay, so first thing I check, is the root isolated? Yes, there's nothing else on that side of the equation, so I'm ready to square both sides. So we have the quantity x plus 1 squared equals the square root of 7x plus 15 squared. Now, to square x plus 1, you have to write it out twice in FOIL. So we have x plus 1
So the next thing is
times x plus 1 equals 7x plus 15.
What about x minus 1?
Alright, so foiling this out, I have x times x is x squared. X times 1 is positive x. You can get those same colors. 1 times x is another positive x, and 1 times 1 is 1. So when doing these kind of problems, if you're going to square like something where it's something plus something squared or something minus something squared, you should always get the first term squared and the last term squared and the same thing in the middle. So here we have x squared plus 2x plus 1 equals 7x plus 15. Alright, now since we have a x squared in here, we need to move everything to one side so we can solve this. So I'm going to subtract 7x from both sides and subtract 15. So I have x squared minus 5x minus 14 equals 0. Alright, so we have a quadratic set equal to 0. I need to see if I can factor it. Since it's just an x squared in the first term, I just need two numbers that multiply to negative 14 and add to negative 5. So we have x minus 7 times x plus 2 is equal to 0. Finally, you solve. So by setting each term equal to 0, if x minus 7 equals 0, then x equals 7, and x equals negative 2. Okay, now I can't accept those solutions until I've checked both of them. So let's go through that. First we'll check 7 by plugging it in. So we have 7 plus 1 is equal to the square root of 7 times 7 plus 15. So 8 equals the square root of 49 plus 15. Well, 49 plus 15 is 64, and 8 is equal to the square root of 64. So this one works. Now I'm going to check negative 2. Negative 2 plus 1 is equal to the square root of 7 times negative 2 plus 15. Now I have negative 1 is equal to the square root of negative 14 plus 15. I already see a problem, right? And that problem is that a square root is set equal to a negative. But let's go ahead and finish it out just to make sure. Negative 1 is equal to the square root of 1. The square root of 1 is 1. So these things are not equal. So this 2 is extraneous. And my only solution is x equals 7. Alright, so this last example, x minus 1 equals the square root of 5x minus 9. The root is isolated, so I'm ready to square both sides. So square both sides. So I have x minus 1 times x minus 1 equals 5x minus 9. So foiling this out, I have x times x is x squared. Then x times negative 1, negative x. Negative 1 times x is negative x. Negative 1 times negative 1 is positive 1. So combine like terms, x squared minus 2x plus 1 equals 5x minus 9. We need to subtract 5x from both sides, add 9 to both sides. X squared minus 7x plus 10 equals 0. So what two numbers multiply to 10 and add to negative 7? X minus 5 and x minus 2 are my factors, making my solutions x equals 5 and x equals 2. So let's check those solutions to see if we have any extraneous. I check 5, so I have 5 minus 1 equals the square root of 5 times 5 minus 9. 4 equals the square root of 25 minus 9. 25 minus 9 is 16. 4 equals the square root of 16. Boom. Worked. Nice. Let's check 2. 2 minus 1 equals square root of 5 times 2 minus 9. 1 equals, what's 5 times 2? 10 minus 9?
1.
Does 1 equal the square root of 1?
Yes.
Boom. How many extraneous solutions do I have? 0 extraneous. How many solutions do I have? 2. X equals 5 and x equals 2. All right. Goodbye.